November 12th, 1942, Richmond, California. A complete cargo vessel, 441 feet long, weighing 14,245 tons, stood ready to slide into San Francisco Bay. The ship had been assembled in 4 days, 15 hours, and 29 minutes. Traditional shipyards needed 6 to 8 months to build vessels of similar size. Yet here stood a Liberty ship, complete and seaworthy, constructed faster than most people renovate a kitchen. The crowd of officials and competing shipyard owners had gathered expecting to witness either spectacular failure or some kind of trick. What they saw instead would transform their understanding of what American industry could accomplish when necessity demanded the impossible. The mathematics were simple and terrifying. German U-boats were sinking Allied cargo ships faster than traditional shipyards could replace them. Britain was starving. The Soviet Union needed supplies. American forces required equipment overseas. Every sunken vessel represented food that wouldn't reach London, tanks that wouldn't reach Moscow, ammunition that wouldn't reach the front lines. Admiral Karl Dönitz had calculated that sinking 700,000 tons of Allied shipping monthly would strangle Britain into submission. By early 1942, his wolf packs were exceeding that target. The Atlantic Ocean was becoming a graveyard, and conventional wisdom said America's shipbuilding industry couldn't possibly build fast enough to matter. Henry Kaiser disagreed, not because he knew better, but because he knew nothing about shipbuilding tradition. The 60-year-old construction magnate had spent his career moving earth and pouring concrete for massive dam projects across the American West. He'd never built a ship, never managed a shipyard, never spent a day in the maritime industry. When he signed his first shipbuilding contract in December 1940, promising to deliver 30 cargo vessels within 2 years, established shipbuilders dismissed him as a naive opportunist who would learn expensive lessons about the complexity of their craft. His ignorance became his greatest weapon. Kaiser walked into Todd shipyards in New York during early 1941 and asked a question that maritime engineers found almost offensive. Why does it take so long? The answers he received sounded less like technical requirements and more like religious doctrine. Ships had always been built a certain way. Skilled craftsmen required years of training. Riveting was the only proven method for joining steel plates. Construction proceeded sequentially from keel to deck because that's how it had been done since iron ships replaced wooden ones. Kaiser's chief engineer, Clay Bedford, had just returned from visiting a Ford assembly line in Detroit. He'd watched automobile chassis moving down production lines with workers installing prefabricated components at each station. Cars weren't built from raw materials in one location by craftsmen who performed every task. They were assembled from parts manufactured elsewhere by workers who specialized in specific operations. Bedford asked Kaiser a question that would change naval architecture forever. Why can't we build ships the same way? The maritime establishment had answers. Ships weren't cars. Hull construction required precision that mass production couldn't achieve. Welding instead of riveting would create weak points that would fail under stress. Training unskilled workers would take longer than using experienced craftsmen. Every objection rested on the assumption that traditional methods represented the only possible approach. Kaiser proposed eliminating rivets entirely. Traditional ship construction relied on heated metal pins hammered through overlapping steel plates. A skilled riveting crew working with perfect coordination could install perhaps 100 rivets daily. Each Liberty ship required approximately 1 million rivets, if built conventionally. Kaiser wanted to use electric arc welding instead, a technique he'd mastered building pipelines. Vice Admiral Emory Land, chairman of the United States Maritime Commission, examined the proposal with deep skepticism. His private correspondence revealed the maritime establishment's horror at the suggestion. Welding had never been proven reliable for hull construction at this scale. The British Navy forbade welding on warship hulls. Kaiser was proposing America bet its supply lines on unproven technology. But Land also recognized desperation. German U-boats were winning. Traditional shipyards using conventional methods required an average of 230 days to build a single cargo ship. At that pace, the Allies would lose the Battle of the Atlantic before American industry could respond. The decision to approve Kaiser's contract represented not confidence but necessity. What rose from the mudflats of Richmond between January and December 1941 looked nothing like traditional shipyards. Instead of massive gantry cranes and longitudinal building ways that characterized established facilities, Kaiser created something resembling an automobile assembly plant. Open areas for prefabrication surrounded 7 parallel building ways. Railroad tracks crisscrossed the facility, designed to move massive steel sections weighing up to 150 tons. Overhead cranes capable of lifting entire ship sections stood every 100 feet. Maritime engineers who visited found the layout almost offensive in its departure from accepted practice. The workers arrived starting in August 1941. Kaiser advertised in newspapers across America, offering wages 20% above standard industrial rates and promising to train anyone willing to work. The first groups included former secretaries, farmers, housewives, and labourers who had never seen an ocean, much less built a ship. Traditional shipyards recruited from established maritime communities where skills passed from father to son across generations. Kaiser was hiring people who couldn't identify a bulkhead from a bilge pump. His training program horrified traditional craftsmen. Welders typically spent 4 years as apprentices learning comprehensive skills. Kaiser's instructors taught specific techniques for specific tasks in approximately 2 weeks. Workers didn't need to know how to weld everything, only how to weld the vertical seams on bulkheads, or horizontal deck plates, or curved hull sections, which they would do repeatedly. The simplification of complex tasks into repeated simple operations borrowed directly from assembly line manufacturing. By October 1941, Kaiser employed over 10,000 workers in Richmond, with fewer than 200 having any previous maritime experience. And something unexpected started happening. Construction times began falling dramatically. Kaiser's first Liberty ship took 197 days to complete. Ship number 2 required 169 days. Ship number 5 required 128 days. Ship number 10 required 97 days. By spring 1942, Richmond was completing Liberty ships in 70 days on average. Traditional shipyards watched with growing alarm as this untrained workforce achieved production speeds that matched their own highly skilled crews. The prefabrication approach that traditional builders had dismissed proved devastatingly effective. Instead of building ships from keel to deck in sequence, Kaiser's yards fabricated entire sections simultaneously across the facility. While one crew assembled a bow section in the prefabrication area, other crews built stern sections, deck houses, engine rooms, and bulkheads in parallel. When sections were complete, massive cranes lifted them onto the building ways where welding crews joined them together. Tasks that previously required weeks now took hours, but the real shock came in November 1942. Vice Admiral Land made an offhand comment to journalists that Liberty ship construction had improved remarkably, but recent speed records still paled compared to what mass production had achieved in other industries. Clay Bedford took the comment as a challenge. He proposed that Richmond Yard number 2 would build a complete Liberty ship from keel laying to launch in under 10 days, cutting the existing record in half. Land authorized the attempt on condition it not disrupt regular production schedules. Every major component for the SS Robert E. Peary had been built, inspected, and staged before the keel touched the building way. The bow section, comprising more than 50 individual pieces, had been fully welded and equipped with anchor hardware, chain lockers, and forward crew quarters before assembly began. The stern section included the completed steering gear, propeller shaft, and aft crew spaces. 4 complete cargo holds, each one a massive rectangular structure of steel, waited to be lifted into position. The engine, a 140-ton triple-expansion steam power plant, had been mounted on its foundation structure and tested before leaving the factory. Starting Sunday, November 8th at 1 minute past midnight, over 1,000 workers operating in carefully coordinated shifts attempted something unprecedented in maritime history. 4 days into construction, the hull was complete. Engine installed, deck houses positioned, cargo hold secured, steering gear mounted. On Thursday, November 12th at 3:30 p.m., just 4 days, 15 hours, and 29 minutes after the keel touched the building way, SS Robert E. Peary slid down the Saifiro, Suida launching rails into San Francisco Bay. The ship was delivered for service on November 15th, setting an additional record of 7 days total from keel laying to full delivery. The crowd that gathered for the launching included Vice Admiral Land and representatives from every major American shipyard. Many had arrived expecting to witness either failure or a compromised vessel that looked complete but lacked functionality. What they saw instead was a fully operational ship that required only minor fitting out before entering service. Land's remarks captured the maritime establishment's forced recognition that everything had changed. 6 months ago, I would have called this impossible. Traditional shipbuilding wisdom accumulated over 3,000 years said you cannot build a proper ship in 5 days. Henry Kaiser has made traditional wisdom obsolete. The psychological impact on traditional shipbuilders was immediate and profound. The president of New York Shipbuilding Corporation, one of America's oldest and most prestigious yards, visited Richmond in December 1942. His confidential report to his board of directors revealed complete ideological collapse regarding traditional approaches. Kaiser has achieved what our industry considered impossible by refusing to accept our limitations. He treated shipbuilding as a manufacturing problem rather than a craft tradition. He simplified where we sought perfection. He standardized where we customized. He trained masses of unskilled workers where we cultivated generational expertise. We must either adopt his approaches or accept irrelevance. By early 1943, Kaiser's influence had transformed American maritime production. 18 shipyards across the country were building Liberty ships using prefabrication and welding. Average construction time had fallen from 230 days initially to just 42 days by mid-1943. The United States was launching 3 Liberty ships daily, more tonnage than German submarines could sink. The mathematics of attrition had reversed. Admiral Dönitz calculations assumed Allied shipbuilding capacity was impressive but finite. He believed that if U-boats sank enough ships, eventually American logistics would collapse. He failed to account for an industry that could build 3 ships daily while he could sink 2. The democratization of skilled work that Kaiser enabled carried implications far beyond wartime production. At peak production in 1944, Kaiser's 7 yards employed approximately 196,000 workers. Over 40,000 were women, representing 27% of Richmond's production workforce. African American workers numbered in the tens of thousands, employed in skilled positions including welding, fitting, crane operation, and even supervisory roles. A level of workplace integration unusual for 1940s America. These weren't traditional craftsmen with generational expertise. They were ordinary people achieving extraordinary results because someone believed they could and organized systems that allowed them to prove it. The quality of Kaiser's ships initially faced skepticism. Some Liberty ships experienced structural failures due to welding defects. 3 ships broke completely in half due to brittle fracture problems. Traditional builders pointed to these failures as proof that shortcuts produced inferior vessels. But the statistics told a different story. Of 2,710 Liberty ships built, approximately 200 were lost to enemy action, a loss rate of 7.4%. The failures led to improved welding procedures and steel specifications that eliminated the problem by 1944. More remarkably, ships designed as emergency vessels with expected service lives of 5 years proved remarkably durable. Many remained in service for decades after the war. The SS John W. Brown, built in 1942, remains operational as a museum ship as of 2024, 82 years after construction. The longevity vindicated Kaiser's approaches more thoroughly than any wartime statistics could. These weren't temporary expedients that sacrificed quality for speed. They were genuine improvements in construction methodology that produced vessels as good as or better than traditionally built ships in a fraction of the time. The prefabrication techniques, welding procedures, and parallel assembly approaches that Kaiser pioneered became standard practice in global shipbuilding. When Japan and South Korea rebuilt their maritime industries in the 1950s and 1960s, they studied Kaiser's Liberty ship program and adopted his approaches as the foundation of their yards. Commander Joseph Kenworthy of the Royal Navy, assigned to the British Admiralty delegation in Washington, watched American production with admiration and envy. His official reports captured the British perspective on American industrial dominance. The United States is building merchant shipping at a rate that exceeds the combined capacity of the rest of the world. Kaiser alone produces more tonnage monthly than the entire British shipbuilding industry. The approaches are crude by Admiralty standards. The ships are inelegant, but they float, they carry cargo, and there are thousands of them. The Royal Navy built the finest warships in the world using traditional craftsmanship requiring years per vessel. The Americans build adequate ships in weeks. Adequate multiplied by thousands defeats P. Perfection multiplied by dozens. That calculation decided the war. Not superior tactics or brilliant strategy or heroic sacrifice, though all played their part. Industrial capacity determined the outcome. Germany entered the war with the world's most experienced military, superior tactics, and technological advantages in multiple domains, but they couldn't match an opponent who could build 3 ships daily while they sank 2. The mathematics were inexorable. Every month that passed saw Allied shipping capacity grow while Axis capacity shrank. By 1943, the tonnage launched exceeded the tonnage sunk. By 1944, American shipbuilding capacity was so overwhelming that ships were being mothballed immediately after construction because there weren't enough cargoes to fill them. The story of how America built Liberty ships faster than U-boats could sink them is ultimately a story about questioning assumptions. Traditional shipbuilders knew ships couldn't be built quickly because they'd never been built quickly. Kaiser didn't know that, so he tried anyway. His success didn't come from superior intelligence or revolutionary technology. It came from refusing to accept that traditional methods represented the only possible approach. The maritime establishment had confused familiarity with necessity, tradition with truth, and conventional wisdom with physical law. Every Liberty ship that slid down the ways at Richmond represented proof that perceived limitations often reflect organizational and conceptual constraints rather than physical impossibilities. The workers who built these ships weren't superior humans. They were ordinary people achieving extraordinary results because someone organized systems that allowed them to prove what they could accomplish when freed from the constraints of tradition and challenged to attempt what experts claim couldn't be done. That lesson demonstrated in the shipyards of Richmond and validated by 2,710 completed vessels remains relevant wherever industries face challenges that conventional wisdom claims impossible. The Robert E. Peary completed its mission and was scrapped in 1963 after 21 years of service, but the revolution it represented endures in every modern shipyard, in every manufacturing facility that uses prefabrication, in every training program that teaches specific skills quickly rather than broad expertise slowly, and in every manager who questions whether impossible truly means impossible, or simply means nobody has figured out how yet. Kaiser proved that industrial capacity isn't fixed, but can be created quickly when necessity demands it. The United States entered World War II with minimal merchant shipbuilding capability. Within 24 months, American yards were producing more tonnage than the rest of the world combined. That transformation didn't require decades of infrastructure development or generations of trained craftsmen. It required someone willing to question why things had always been done a certain way and brave enough to try something different when the answer was just because